Hello students. In the previous video, we already started one of the important chapter, P block elements. In that, we already discussed about what are P block elements. What are P block elements? The last differentiating electron enters into the p orbital, and we know the group 13 to group 18 elements are belongs to the p block elements, and these p block elements are also called as representative elements. Atomic number, general electronic configuration, all these concepts are discussed in previous video. Students, we know the general electronic configuration of p block elements is rare gas NS2 NP126. Please remember this point. General electronic configuration of p block elements is rare gas NS2 NP126. Now, move to the detailed study of group 15 elements now. Group 15 elements or 15th group elements is how to remember the 15th group elements. For this, in the previous video, I already given one trick point. Elements of 15th group elements. Atomic number, electronic configuration. Make 3 columns. Electronic configuration. Before going to the 15th group elements, first the general electronic configuration. General electronic configuration of group 15th elements is rare gas NS2 NP3. General electronic configuration of group 15 elements is rare gas NS2 and NP3. Now come here. What are the elements present in group 15 elements? Means group 15 elements are nitrogen, phosphorus, arsenic, antimony, bismuth. How to remember this? Take one statement. Nepal, Pakistan, Australia, sab Bikhari. This point helps to remember the group 15 elements. Nepal means it indicates nitrogen, Pakistan means phosphorus, Australia means arsenic, sub it indicates antimony, and bismuth. Yes, nitrogen atomic number is 7. Phosphorus atomic number is 15. And arsenic, it is 33. Antimony, this is 51. And this one, 83. Bismuth is 83. Next, electronic configuration. Nitrogen, it is helium 2s2, s2 2p3. Next, phosphorus, neon 3 3s2 3p3. Next, argon 3d10 4s2 4p3. Next, krypton antimony, krypton 4d10 5s2 5p3. Next, bismuth, xenon 4f14 5d10 6s2 6p3. Please remember these points. Nitrogen atomic number is 7 and its electronic configuration is helium 2s2 2p3, and phosphorus neon 3s2 3p3, and arsenic argon 3d10 4s2 4p3, and krypton 4d10 5s2 5p3, and bismuth xenon 4f14 5d10 6s2 6p3. One important note point related to the group 15 elements is, see here, these group 15 elements are also called as nitrogens. Group 15 elements are also called as nitrogens. Why these group 15 elements are called as nitrogens? Remember students, these group 15 elements having suffocating order. Group 15 elements having suffocating order. Suffocating order means, ಏನು suffocating order ಅಂದ್ರೆ ಉಸಿರುಗಟ್ಟಿಸುವಂತಹ. ಇವೇನು ಗ್ರೂಪ್ 15 ಎಲಿಮೆಂಟ್ಸ್ ಉಸಿರು ಕಟ್ಟುವಂತಹ ಗುಣಲಕ್ಷಣಗಳನ್ನ ಒಳಗೊಂಡಿದ್ದಾವೆ. ಅದಕ್ಕಾಗಿ ಇವಕ್ಕೆ ನಿಕೋಜನ್ಸ್ ಅಂತ ಕೂಡ ಕರೀತಾ ಇದ್ದಾರೆ. ರಿಮೆಂಬರ್, ಗ್ರೂಪ್ 15 ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಆಸ್ ನಿಕೋಜನ್ಸ್. And they are involved, means group 15 elements are involved in the formation of a high explosive substance like TNT, trinitrotoluene. Yes, because of these points, the group 15 elements are also called as nicogens because they have suffocating odor. Next, come to the occurrence of group 15 elements. Occurrence of group 15 elements, very important. See here, nitrogen, it is available 78% by volume and 74% by mass. Remember, nitrogen, it is available 78% by volume and 74% by mass. Usually, one general point related to nitrogen, please remember, NaNO3 means sodium nitrate. It containing nitrogen. Usually, this is called as chili saltpetre. ಚಿಲಿ ಸಾಲ್ಟ್ ಪೇಟ್ರಿ ಅಂದ್ರೆ ಚಿಲಿ ಉಪ್ಪಿನಕಾಯಿ ಅಂತ ಇದನ್ನ ಕರೀತಾರೆ. ಸೋಡಿಯಂ ನೈಟ್ರೇಟ್ ಅನ್ನ ಚಿಲಿ ಉಪ್ಪಿನಕಾಯಿ ಅಂತ ಕರೀತಾ ಇದ್ದಾರೆ, ಚಿಲಿ ಸಾಲ್ಟ್ ಪೇಟ್ರಿ. Similarly, KNO3 potassium nitrate, this is also called as Indian salt patre. Indian salt patre. NaNO3 is chili saltpetre. Potassium nitrate is Indian saltpeter. Yes. Next, phosphorus. Phosphorus It is usually available in earth crust in the form of phosphate rocks. Phosphorus, it is usually available in earth crust. ಭೂಮಿಯ ಒಳಭಾಗದಲ್ಲಿ ಕಂಡು ಬರತಕ್ಕಂತದ್ದು phosphate in presence of phosphate rocks. If you take an example of Ca3 PO4 twice, it's one of the calcium phosphate. Yes, phosphorus, it is available in earth crust in the form of phosphate rocks. Next, arsenic, antimony and bismuth. These are less abundant and usually available in the form of minerals of sulfide. Arsenic, antimony, bismuth, these are usually less abundant and available in the form of minerals of sulfide. If we take an example, AS2 S3, AS2 S3, Sb2 S3, Sb2 S3, another one Bi2 S3. These are some examples for sulfide minerals containing arsenic, antimony and bismuth. This is about occurrence of group 15 elements. Next, general properties. General properties of group 15 elements. Some general properties are discussed here. In that first point about atomic size. Atomic size or atomic radius. Take atomic radius, atomic size. What happens if you move down the group in presence of group 15 elements? What happens to the atomic size? Yes, if we move down the group in presence of 15 group elements, atomic size increases due to the increase in the number of cells. ಇಲ್ಲಿ ನೋಡಿ, ಅಟಾಮಿಕ್ ನಂಬರ್ ಏನಾಗ್ತಾ ಇದೆ ಇಲ್ಲಿ ನಾವು ಕೆಳಗಡೆ ಅಂದ್ರೆ ನೈಟ್ರೋಜನ್ ಇಂದ ಫಾಸ್ಫರಸ್, ಫಾಸ್ಫರಸ್ ಇಂದ ಆರ್ಸೆನಿಕ್ ಈ ತರ ಕೆಳಗಡೆ ಮೂವ್ ಆದ್ರೆ ಅಟಾಮಿಕ್ ನಂಬರ್ ಏನಾಗ್ತಾ ಇದೆ, ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತಾ ಇದೆ. ಇಲ್ಲಿ ಅಟಾಮಿಕ್ ನಂಬರ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ಅಟಾಮಿಕ್ ಸೈಜ್ ಕೂಡ ಏನಾಗ್ತದೆ, ಇಲ್ಲಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. ಯಾಕಂದ್ರೆ ನಂಬರ್ ಆಫ್ ಸೆಲ್ಸ್ ಏನಾಗ್ತಾ ಹೋಗ್ತಾವ, ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತಾವ. ರಿಮೆಂಬರ್, in presence of 15 elements, if we move down the group, atomic size increases. Another point, compared to nitrogen and phosphorus, if you move down the group, there is a gradual increase in the atomic size. And another, next, phosphorus to arsenic, like this, there is a small increase in the size. Means overall, if you move down the group, the atomic size increases due to increase in the number of cells. Next, second point, ionization energy. Ionization energy. What is ionization energy? It is the amount of energy which is required to remove an electron of an isolated gaseous atom. Please remember, this point is already learned in previous year. In that ionization energy, it states that the amount of energy required to remove an outermost electron in an isolated gaseous atom is called ionization energy. happens to the ionization energy in presence of group 15 elements? Remember, if we move down the group, the ionization energy decreases. Ionization energy decreases down the group. Ionization energy decreases down the group. Very important, please remember. Yes. From nitrogen to phosphorus, there is a observable decrease in the ionization energy, and if we move down the group from phosphorus to arsenic to antimony, there is a small decrease in the ionization energy values. Yes. Overall, you remember, if we move down the group in presence of group 15 elements, ionization energy decreases. Next, electron affinity. Electron affinity. Yes, what is electron affinity? The amount of energy which is released when an electron added to the outermost cell of an isolated gaseous atom. Electron affinity is defined as the amount of energy released when an electron is added to the outermost cell of an isolated gaseous atom. Yes, if we move down the group, means if we move from nitrogen to bismuth, electron affinity also decreases down the group. There is a gradual decrease in the electron affinity from nitrogen to bismuth. Next, electronegativity. Electronegativity. What is electronegativity of an atom? It is the ability of an atom to attract the shared pair of electrons. It is the ability of an atom to attract the shared pair of electrons. Remember, electronegativity also decreases. In presence of group 15 elements. If we move down the group, in presence of group 15 elements, electronegativity decreases. Yes, one more point here. If we compare group 15 elements with group 14 elements, ionization energy, electron affinity and electronegativity. If you compare these group elements with the 14 group elements, these points, ionization energy, electron affinity and electronegativity are higher than those of group 14 elements. Because if we move along the period, these points, ionization energy, electron affinity, electronegativity are increases. But if we move down the group with the respective group of elements, these points decreases down the group. Please remember. Next, very important, another general property, oxidation state. Oxidation state. Oxidation states. Yes, students, usually group 15 elements having oxidation state -3, +3 and +5. Usually the oxidation state of group 15 elements is -3, +3 and +5. This shows this type of oxidation states. Yes, you know, in the valence cell, in presence of group 15 elements, there are 5 electrons. In the valence cell, there are 5 electrons. If you observe, there is a 5 electrons in the valence cell of group 15 elements. By gaining or sharing means losing, by gaining or losing of electrons, these get stability. This process shows the oxidation state of particular element. Usually in the valence cell there are 5 electrons. To get a stability, they loss or gain the electrons. It shows the oxidation state of particular element present in a group 15 elements. Okay, in that, first come to the point of nitrogen. Yes, nitrogen shows the oxidation state from -3 to +5. -3 to +5 means +5, +4, +3, +2, +1, -1, -2, -3, etc. Nitrogen shows -3 to +5 oxidation state. If you take an example, NS3 ammonia. Here hydrogen oxidation state is +1, therefore 3 into +1 it becomes +3. Therefore the nitrogen oxidation state here is -3 because sum of all these atoms equal to 0. I think this is already studied in previous year oxidation state chapter, means redox reaction chapter. In that already you know how to calculate the oxidation state of an atom. Yes. In NS3, the nitrogen oxidation number is -3. Next, N2. N2H4. Here 4 into means this is +4, and here the sum of the total it becomes equal to 0 means the value of N2 here it is -4, but here there are 2 nitrogens, one nitrogen value is -2. Yes, next N2 molecular form, therefore its oxidation number is means oxidation state is 0. In N2O, oxidation state of oxygen is always -2, therefore N2 is +2, but there are 2 nitrogen, one nitrogen value is +1. These are some examples for oxidation state of nitrogen containing compounds. Yes, but you remember, usually nitrogen shows the oxidation state between -3 to +5. Next, phosphorus. Phosphorus also shows the oxidation state between -3 to +5, but +2 oxidation state usually not appears in presence of phosphor containing compounds. If you take an example, PH3, here phosphorus oxidation state is, here H means oxidation number is +1, therefore it becomes +3. 3 into +1 +3, therefore it becomes -3. Overall it becomes equal to 0. Yes, minus 3 plus 3 equal to 0. The phosphorus oxidation number is minus 3. In presence of PCl5, yes, Cl means halogens having minus 1 oxidation state. 5 into minus 1 minus 5u. Therefore, the oxidation number of phosphorus plus 5 is equal to plus 5. PCl3 similarly. Yes, these are some examples for oxidation of phosphorus containing compounds. But remember, phosphorus also shows the variable oxidation states between minus 3 to plus 5. One important thing related to nitrogen and phosphorus is nitrogen and phosphorus shows variable oxidation state. Yes, next, very important thing, arsenic, antimony and bismuth, they do not show variable oxidation state. Very important, arsenic, antimony and bismuth, these do not show variable oxidation state because of the metallic character or due to the inert fair effect. Very important, remember students. Nitrogen and phosphorus shows variable oxidation state, but arsenic, antimony and bismuth, they do not show variable oxidation state due to the metallic character or due to the inert fair effect. They have stable oxidation state of plus 3. Arsenic, antimony and bismuth shows plus 3 oxidation state. Stable oxidation state of plus 3. Yes, one important word came here, inert pair effect. What is inert pair effect? Here the outer s electrons, remember when you observe this electronic configuration, the outer s electrons do not share. In presence of inert pair effect, the outer s electrons do not share and they are held together by the nucleus. Very important. In presence of arsenic, antimony, bismuth, the inert pair effect takes place. It shows. ಅಥವಾ ಅದು ಏನು ತಿಳಿಸ್ಕೊಡ್ತದ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಇರ್ತಕ್ಕಂತ ಎಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅವು ಬಾಂಡ್ ಫಾರ್ಮೇಶನ್ ಅಥವಾ ಕ್ರಿಯೆಗೆ ಒಳಪಡುವುದಿಲ್ಲ. ಅವು ಏನಾಗ್ತವೆ, ನ್ಯೂಕ್ಲಿಯಸ್ ಇಂದ ಆಕರ್ಷಣೆಗೆ ಒಳಪಟ್ಟು ಅದು ನ್ಯೂಕ್ಲಿಯಸ್ ಇಂದ ಬಂಧನಕ್ಕೆ ಒಳಪಡುವಂತ ಕೆಲಸ ಆಗ್ತದೆ ಅಲ್ಲಿ. Inert pair effect, it explains the outer s electrons do not share and they are held together by the nucleus. Yes, one more important point. If we move down the group in presence of group 15 elements, plus 5 oxidation state decreases. Remember, in presence of group 15 elements, if we move down the group, plus 5 oxidation state decreases and plus 3 oxidation state increases. Why this happens? Because of inert pair effect. Plus 5 oxidation state decreases if we move down the group, plus 3 oxidation state increases if we move down the group. Yes, this is related to the oxidation state of group 15 elements. Very important, please remember students. Next, general properties, physical properties. Physical properties of group 15 elements. Yes, in that my first point is all 15 group elements are polyatomic. 15 group elements are polyatomic. Yes, second one. In presence of group 15 elements, nitrogen, it is one of the diatomic gas. Nitrogen is diatomic gas because it is available in N2 form. Nitrogen is diatomic gas and others are solids. Others are solids. Yes, next point. Nitrogen and phosphorus. Nitrogen and phosphorus are non-metals. Nitrogen and phosphorus are non-metals. But arsenic and antimony. Arsenic and antimony are metallites. Next, you know bismuth, it is one of the metal. Bismuth, it is one of the metal. Yes. These are the some physical properties of the group 15 elements.